Today we are going to look at scientific notation, just a quick and easy recap on how to put numbers into scientific notation and how to take those numbers back out of scientific notation. So when we think of scientific notation, there are essentially two parts to the number. There's a number between 1 and 10, and then we have 10 raised to a power. It's important to remember that whether you are writing the number in scientific notation or just normally in standard notation, that they mean the exact same amount. It's just two different ways to write that number. Let's start by looking at an example. Scientific notation is handy when we have a very, very large number or a very, very small number. Let's say that we have something like this, 150 billion. So eventually, once a number gets too big or too small, your calculator is not going to have enough room in the screen, and your calculator will automatically convert it to scientific notation. So when it's converting it to scientific notation, it's not doing any math to the number, it's just writing it in a different format. The first step to writing a number in scientific notation is to locate the decimal. If there's no decimal written in the number, the decimal is found at the end. You then want to move your decimal to a place that gives you a number between 1 and 10. So if I look at my number here, I'm going to move the decimal from its current location to a spot that gives me a number between 1 and 10. The only place that works in this number is between the 1 and the 5. If I put it after the 5, I would have 15, and now I'm out of my 1 to 10 range. So I'm going to put the decimal in its new spot right between the 1 and the 5. But when I do this, clearly 1.5 is not the same value as 150 billion. So in order to make sure they are the same, we're going to add the second part, times 10 raised to a power. Now, in order to determine the power, we are going to look at the decimal's original location and its current location. We're going to count how many places we had to move it. So start at its original location, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. That means that our exponent is going to be 11. These two numbers represent the exact same amount. It's just two different ways of writing the number. Let's take a look at the same thing, but this time with a really small number. This time, we have 0.000000235. All right, so if we want to take this number and convert it to scientific notation, we're going to do the same thing. We're going to find the decimal. This time it's a little bit easier because it's already written there for us. And then we're going to move that decimal to a place that gives us a number between 1 and 10. So this time I'm going to put it between the 2 and the 3. It's important that I keep all of the non-zero digits after the decimal when I am writing this out. So 2.357 is the only place that I can put the decimal to give me a number between 1 and 10. Then I'm going to do 10 raised to a power. Now, in order to figure out the power, I again am going to count how many places I moved the decimal from its original location to its new location. So originally it was here, 1, 2, 3, 4, 5, 6, 7, 8, 9. I had to move it 9 spots, so my exponent is 9. Now the one thing I need to be careful about is the sign that belongs on the exponent. Notice that this number here is smaller than 1. When your original number is smaller than 1, your exponent must carry a negative sign. So this would be 2.357 times 10 to the negative 9th. When your beginning number is greater than 1, your exponent will be positive, like in the first example. One last thing to keep in mind is how your calculator formats this. When we are doing math with really large or really small numbers, our calculator will often convert to scientific notation. When my calculator converts something to scientific notation, rather than writing 1.57 times 10 to the 7th power, my calculator will often write that as 1.57 E7. When you get that number out of your calculator, it is not giving you an error. Instead, this number is exactly the same as 1.57 times 10 to the 7th power. Let's do an example where we go from scientific notation into standard notation. All right, this time for my example, I have 3.482 times 10 to the negative 3rd power. Remember that this number here is telling you how many places you need to move the decimal. So I need to move the decimal 3 places, but I need to make sure that I move it 3 places in the correct direction. So if I have a negative number, I know that my original number must have been less than 1. In order to get a number less than 1, I'm going to have to move my decimal 3 places to the left. Notice that I made little swifties to hold the zeros. So I'm going to fill those in, and my final number would be 0.003482. That is the exact same number as 3.482 times 10 to the negative third. I hope this helped clear up some of your questions with scientific notation. Remember that in chemistry, we use numbers that are very, very large and numbers that are very, very small. So this is helpful to know, especially when you are dealing with things like the mole. Thank you for watching. Comment below if you have any questions. And I hope that you check out my other videos. Don't forget to like and subscribe.